Hi, in this lecture we will be talking about a very important machine learning concept, what you call feature encoding. So while doing that, we will be using some notebook coding, and the links are provided in the description box. The plan is we will be learning about two encoding techniques, what you call level encoding and one-hot encoding. So let's start with some tabular data. So you can quickly figure out that here we have some records in a table with 3 columns. So we are talking about some people with their age, height, and weight. So all values are numeric. So if we ask you to develop a regression model, you are good, right? Because all the data is numeric. Or a KNN model, we are good. However, if we add another column, so here the values are categorical. More specifically, we added the gender values of each person, and now things actually are a little different because you cannot plug them into a vector space to do nearest neighborhood. Neither you can do a regression model. So you need to encode these values, and one easy way is you just do some numeric alignment. For example, you put for female 0 and male 1. So this works. Now I have another column added, which is the color preferences of each of the person. Again, the same idea works, that you just add some integer values to each categories. For example, here we have added 0 for red and 1 for green and 2 for blue. This works, and we call this kind of assignment as level encoding. So the idea is quite simple. So for example, we have 2 categories for sex or gender. So we just randomly pick 2 values and assign to each categories. Here we have 3 categories. You pick 3 values and then just randomly assign them. So this is the famous level encoder. Very simple idea. But can you figure out that by doing this kind of random assignments, are we doing fair job or we have some issues? You may have figured this out because we enforced some numerical relationship by this assignment. More specifically, we are telling that red is closer to green than blue. So what will happen if you analyze this data, because there is a relationship, because the first row is all about a young kid, and compared to ages, she is the youngest. Okay. However, in terms of their color preferences, we cannot tell that the first record is closer to the third record, right? So by doing this, we are enforcing this bias. So do you know some better way? Yes, we know about another encoding, what we call one-hot encoding, that actually debias that definition. So how many color we have? 3. Red, green, and blue. So instead of having one number for each value, we use 3 bits to represent those values or encode those values. For example, here, how many colors we have? 3. So we take 3 bits to represent each color. For example, here we have represented the first column 1 for red, the second column 1 for green, and then the third column 1 for blue, and we fill up the rest with zeros. So this is the general idea of one-hot encoding. And how do we confirm that this definition don't have that bias? So let's look at their position in the vector space. If you have identified that this is a 3-dimensional representation of those categorical values, and if you plug them in the vector space, you will find out that the distance between each of the data points are the same. This is how we were able to debias the definition. But anyway, the whole idea is we learned about two encodings. One is the level encoder. So you randomly assign any integer values to your categories. And in the one-hot encoding, you have created independent columns based on the number of categories your variable has. Okay. So how about other data? For example, if you are doing a dog versus cat classifier, so because you have two categories, you can assign 1 and 0 to each of these categories, right? So if you have three categories, then if you want to do level encoding, you just randomly assign any three integer values, then we are good. But if you want to do one-hot encoding, then you have to follow this way. So this rule applies to any categorical values. For example, if you want to encode the days in a week or months in a year or your words in your dictionary. Okay. So now I'll be going to the notebook part of the presentation. So here we'll be doing a regression modeling task that will predict the medical insurance cost based on the features like age, sex, BMI, and some other categorical features. So let's load the packages, and we are loading the data from my GitHub repo. If you see the content of the data frame, you can see that you have age values, then sex values, then BMI, and then smoker, and then region, and then here your charges. Okay. So next I am going to split the data into features and labels data frame. So this your feature data frame looks like. And you can clearly see that you have numeric values and categorical values. And I'm doing some plotting to convince that we have some linear relationship between the target variable and the independent variable. But the question is, if you want to learn a linear regression model, then you need to encode these categorical features. So first we are separating which feature is numeric and which feature is categorical by this piece of code you can check it with. And then this is the famous level encoder implementation of scikit-learn. And we will only encode the categorical features. It's very simple. You just fit transform feature by feature, okay? Sex, smoker, and region. These three columns are categorical. So we are iterating over the categorical features, and we are fitting and transforming each data frame columns. Okay. As soon as you have done that, you can quickly see that all the column values now are numeric. Okay. So that's what our goal was. If you want to do one-hot encoding, you have to do a little bit work, but you don't need to worry because pandas, they have a method what you call get dummies. So as soon as you have done that, so here we are showing only for the sex column, we had male, female, male, male, male. Okay. So as soon as you have asked this piece of code to transform that, so we have two values for the gender or sex column. So as soon as we have done that, it created two columns and filled their corresponding values. For example, the first row was female, right? So female was true and then the male was false. Okay. Now we do that for all the columns. And if you found that age is as it was, then BMI, and then children, and your sex column actually expanded to male and female. The smoker column expanded to no, yes, and then the region column expanded to northeast, northwest, southeast, and southwest. Okay. And you can figure out that these are Boolean values, but you can consider them as 0 and 1. Okay. So this was all about the feature encoding part. feel free to ask me if you have any questions. Okay, but I strongly suggest that you take a copy of this notebook and run it and try to understand what this code does.